Hello, learners of math. We are going to be focusing today on analyzing graphs of functions a little bit more in depth than we have before. We have done a lot with exploring zeros and intersections and even shaded regions, but we haven't really talked about what happens on graphs, where they minimize and maximize and, go up or down and why that happens. So that's what our focus is going to be today. We're going to pull up, even though that says polynomial, we're going to analyze an absolute value graph because we have done a lot of those in the past, and those are a little bit easier to work with. So I want to start by talking about how this absolute value graph moves. I'm going to pull up on Desmos for a minute, and if you put what we call the parent function in of absolute value of x, you know that's just a V shape that's opening up and it's centered around the origin. And so we're going to try to get this function to transform to look like this. If I have a negative on the outside, that'll flip it, so that'll reflect the graph. So let's make a note of that. That's going to reflect. If I'm subtracting 3 inside, then that's actually going to bring it to the right 3. And this plus 5 outside is going to bring it up. It's going to add 5 to all your values, so it's going to bring it up 5. So just kind of visualizing what has happened, we can graph this in Desmos, and we are able to get these points too. So, it has a few different points that you can get. It's got the x-intercepts. These are your zeros. -2 and +8. But it also has a point up here. That's your vertex. That's your maximum. If it was at the bottom, it would be your minimum. So you can click on that. And Desmos does give you one other point on here that you can get, besides going into your table. One just kind of disappeared from me. And that's 0, -2. That's the y-intercept, but we really won't need this for the problem, so I'm going to leave that off. But anyway, that's how to analyze the graph, and we can do more with this graph by analyzing the tables if we need to. But let's talk about a couple of terms that I hope are familiar with you, and that's domain and range. The domain on this graph, really, what x values are you allowed to plug into this function? Is there anything we can't plug in, I guess is the better question. And that answer would be no. I mean, we have any number that can be plugged into this table and get an output. If you bring up a table, you can put in any value of x. So I could put in 100, and it's going to give me -92. Or I could put in -1,000, and I get -998. And really, I mean, I can absolute value whatever number I want. So if that is the case, then your domain, we'd simply say all real numbers. And you're going to write it in interval notation. So it's going to look like -infinity to +infinity. So basically that's saying I can plug in any value into this and get an output. The range for absolute values is a little bit more limited because they're either going to max out or bottom out. In this case, it's got a maximum. So there are no values of y below the maximum y value. So because y equals 5 there and everything's below it, your range is going to be all the values of y less than or equal to 5. Less than or equal to 5. If it was above the graph, it would be greater than or equal to 5. We want to write this range as an interval notation. So it's going to look like -infinity because all the values below are represented in the negative direction. And then it's going to cut off at 5. And anytime it cuts off, because it's equal, you're going to put a bracket on there as opposed to a parentheses. If it was just less than 5, you would put a parentheses. So that is your domain, and that is your range for this graph. Now let's talk about something called end behavior. End behavior is how the graph reacts at the left and the right side. If you look at the arrows, it should indicate in what direction it's pointing. The left end behavior is always going to say as x approaches negative infinity, because the left side of your graph on the x-axis is negative numbers, and so it's going to go to negative infinity as it goes to the left. The right side of your graph on the x-axis is positive numbers. So we have to look at, it's always going to go left, it's always going to go right. So we have to look at the y value. F of x is just y. And we got to see what's happening to the graph as it goes to the left. So on the left, this graph, it is pointing downward as well. So what represents down on the y-axis? Well, that's going to be negative infinity. So f of x, or y, approaches negative infinity in this problem because it's going left and down. So that's what you want to come up with. You want to come up with that negative infinity here, because that's going to go left. But if the graph opened upward as it went to the left, then that would change to a positive infinity. The right end behavior, well, that's going to the right. So as x approaches infinity, or positive infinity, what happens to the y value? Well, this is an absolute value. They form a V shape, or in this case, an upside down V. So it's also going to go right and down. So because it's going down, it's going to also approach negative infinity. So we're going to say right and down. And we can, that end behavior can change depending on what you have going on. So for instance, if I looked at another function, let's say it was, let's just say it was the absolute value of x. Well, this graph goes left, but it goes up. So the left end behavior would be infinity. And this graph goes right and up, so the right end behavior would be infinity. So if it goes up, it's going to be infinity on those ends. If it goes down, it's going to be negative. Let's talk about increasing and decreasing. Increasing intervals are going up as it goes to the right. So if the graph goes up and to the right, the graph is going to be increasing. A decreasing interval would go down and to the right. So we're always thinking about from left to right, what is happening. But the intervals are really focusing on x values. So we want to look at the x-axis. We're looking at numbers here that determine if the graph is going to be going up or down. So let's look at this graph. I'm going to talk about increasing first. So the graph is increasing. Now don't pay no attention to these arrows here, okay? Pretend those arrows are non-existent. In fact, I'm gonna white them out for a second because I don't want them messing up your train of thought. Okay, this graph on the left side, as it goes to the right, is going upward. And it's going to go upward until it hits that vertex. And that vertex happens to be at 3, 5. But that whole graph, all the way from the left, because that's going from forever, is going to be increasing until it hits to x equals 3. So that graph is increasing, we'd say is increasing on the interval from negative infinity, because it's starting from the left all the way to the left, until it hits 3. And of course, at the y value 5, then it turns back around and decreases. So the increasing interval, we say increasing from negative infinity to 3, but the better way to say that would just be negative infinity, comma 3. That would be considered the increasing interval. Now let's look at decreasing, and maybe I should use a different color to kind of note the difference. This graph is going downward. It happens to be going downward here, starting at 3 again, And it's going to go down forever. You know, there's no, it's going to keep going. So that arrow down is going to be decreasing from 3 all the way until the very right, which is positive infinity. So we say decreasing from 3 to infinity, or simply 3 comma infinity in parentheses. So that set of parentheses can represent a decreasing interval. So decreasing is going down as it goes to the right, increasing is going up as it goes to the right. Okay, and then another type of interval we're going to talk about is positive and negative. Okay, so we got to imagine that your x-axis is a dividing line in this problem. So, you know, and the increasing was all about the maximum value here and where it turned around. With positive and negative, it's all about where it hits the x-axis, because all the stuff above the x-axis is positive. So we'll use brown for positive. Positive is above x-axis. Whereas negative, let me use orange, is below the x-axis. So the intervals are going to be, you know, we're going to write them similar to this, but it's going to be using the values where it hits the x-axis, because that's where it changes, okay? This interval is going to be above the x-axis between what 2 points? Even though that's going down here, it's still positive because it's above the x-axis. So that's going to be a positive interval between these two x values, between -2 and +8, because between those two x values, that graph is above the x-axis. So on which x interval is the graph positive? Well, it's positive from -2 to 8, or you could simply say -2, 8. So where's it going to be negative? Well, here it actually has 2 negative intervals. Okay, one on the left side of that -2 and one on the right side. Now let's look at the intervals here. Now the negative interval, it's going to be negative from, this pen keeps getting in the way, from all the way to the left side, which is again negative infinity, up until it hits -2. So it's going to be negative from, it's going to be below the x-axis. Remember, negative is below the x-axis, from negative infinity to -2. But that's not the only one. Negative infinity to -2 is one of the negative intervals. The other negative interval is going to be from 8, and it's going to the right. Now remember, we're talking about x values, so it's going from, let me put this negative infinity up here. It's negative from negative infinity to -2, but it's also negative from 8 to infinity. As the graph goes to the right, the graph will be below the x-axis. So we can say and 8 to infinity. And more properly, we want to write it like this: -8, comma -2. Usually we use a U, that stands for the union, and 8 to positive infinity. 2 negative intervals, so we got to write it like that. Okay, the back side has one with a polynomial. So read through that and see if you can identify some of the intervals, and then we will check with it in a second. All right, hope you've got a chance to read through this, and it's laid out just like the absolute value one, but I wanted you to see it, how it's going to be with polynomials, because most of our work's going to be with polynomial functions, not absolute value. So if we look at this function, I already have it graphed, and you can get all those key points. I'm talking about the zeros, the max, and the min. And there's really no work to get those. You just got to click on them. Those are your zeros. Those should line up with these three coordinates. And I'm going to hide them for a minute, and we'll focus on our max at 1.279 and our minimum at the x value of 3.387. So hopefully you can identify that. And I'm going to hide that for a little bit. Let's talk about our domain and range. Okay, so on this problem, just like the absolute value problem, there is no value of x that I cannot plug into this function. So if you pulled up a table, there isn't any undefined numbers. That graph is seemingly going to go down forever and up forever and left forever and right forever. It'll keep going left, even though it doesn't look like it's going left right now. It looks more downward. It's still going left because you can adjust, or you can plug in anything you want. So I could plug in negative 2 million. It's going to give me a huge negative number. That's in scientific notation. But I still can plug that in, and I can plug in 2 million. I can plug in 20,000. Sorry, I said negative 2 million, but that's negative 20,000 and positive 20,000 still give me output values. Anyway, I hope you get the idea that you can plug in any x value. So therefore my domain is going to be all real numbers. And of course that means negative infinity to positive infinity. The range in this case, in the absolute value, it had a clear max and a clear minimum. This doesn't. I mean, it has what we call a relative max here, if you want to call it that. But it doesn't have an absolute maximum. It will go up forever, and it doesn't have an absolute minimum. It will go down forever because of these arrows. So our range is covered. Everything in y is going to be available for us. Therefore, our range is going to also be the same thing, all real numbers. So you'll see some graphs, that have a minimum or maximum, and your range will be either above or below that number. Let's talk about end behavior. So the left end behavior, remember, the negative infinity for the x value. What's happening on the graph as it goes to the left? Well, it looks like it's pointing down. It's going to keep going down as it goes to the left. So left and down means that as x approaches negative infinity, so in other words, as x goes to the left, f of x, y, will go down. And we represent down by using negative infinity. Now the graph on the right, it's not going in the same direction on the right, it's going upward on the right. So the right end behavior is going to be focusing on changing that to positive infinity. So as the graph goes to positive infinity, as x goes to the right, y will go up. Therefore, that's going to go to positive infinity, not negative infinity. So left and down, right and up represents this. So let's talk about increasing, decreasing, positive, and negative. Increasing and decreasing is all about where it turns, not where it crosses the x-axis, but where it turns. So this graph is increasing from all the way to the left up until it hits this value of x. Now that value of x we have right here, it's about 1.279. It's going to increase there, but it's also going to increase here. from this value of x all the way till it reaches positive infinity. So it's going to have two increasing intervals. It's going to increase from negative infinity up until it hits, what is that value? 1.279. That's an increasing interval. But it's also going to increase from this value of x, which is 3.387. So I'm going to put a little u for and, 3.387. And it's going to keep increasing forever to the right. So we're going to say to positive infinity, because that's going to go forever to the right. And so we'll have our two increasing intervals. So it's increasing here, and it's increasing here. This graph will have one decreasing interval. And that's kind of in the middle here. Notice that it's going down as it goes to the right. Now, it's decreasing between these same two x values that kind of flanked our endpoints for these intervals. So it's going to be decreasing between those two x values. So between 1.279 and 3.387. So we say it's decreasing between 1.279 and 3.387. And finally, let's talk about positive versus negative again. Positive intervals are always going to be above the x-axis, and negative intervals will be below the x-axis. So it's really about where does it hit the x-axis to determine our positive and negative intervals. So this graph has a positive interval here. And that interval is positive between the two x values at these points, which happen to be what appears to be 0.697 and 2. So it's going to be positive between 0.697 and 2. Again, where does it hit the x-axis? That's going to determine your positive intervals. We will not need these for positive and negative intervals. So we won't need our maximums or mins for that. It's also going to be positive over past this x value. So if you look at 4.303, anything to the right of that is positive as well. So from 4.303 all the way to the right, which is represented by positive infinity, that would represent a positive interval. So I'm going to put a little u to join them together, and we say 4.303 to infinity. Those are my two positive intervals. This is going to also have two negative intervals. So the negative intervals are below the x-axis. And those intervals are going to be all the numbers from the very left side, which we call negative infinity. So it's going to be from there. And then remember, it cuts off here. That's your 0. So that same 0 we used to start our positive interval is going to end our negative interval, because it becomes positive after that point. So it's negative, then it's positive, then it turns to negative again. And where is it negative? It's going to be negative between this x value, which is 2, and it's below the x-axis all the way until it hits 4.303 again. So that's going to be your other negative interval, 2, 4.303. And you can see those are basically just between those two. So together we've covered all the intervals, positive and negative, increasing versus decreasing. It is possible to have sometimes a graph that is positive but decreasing and negative but increasing. So for instance, if you look at this increasing interval, part of it's negative. You know, the part under the graph, under the x-axis is negative. Part of it's positive, the part above the x-axis. But then the decreasing interval, this part of it's positive, but below the x-axis, that part of the decreasing interval is negative. So they can mix and match, and they really don't relate to each other than they can overlap a little bit. I hope that clears some things up and is beneficial for you too. You want to try, there's going to be 2 assignments on this one that I'll have you do. That's the Unit 3, Day 6 practice on Canvas. And there's also going to be a little bit of a Delta Math for some guided practice on that as well. So I hope that you are successful at it, and let me know if you have any questions. I'd be more than happy to help. Thanks for watching.